Greetings, math fans. All right, so this is chapter 3B. And what we're going to do is we're going to talk about the chain rule. So this is day 1. And it's the chain rule. Okay, very important part of differentiation. So basically, we know how to differentiate the sine of x and also x squared plus 4. Okay, but how about the sine of x squared plus 4? All right, that's a little more brutal. Okay, it's pretty easy, right? Derivative of sine of x is, cosine of x, and derivative of x squared plus 4 is 2x. It's pretty easy. But actually, when you put two of them together, it becomes a little more complicated. So we're going to get back to this, but before I actually start this one, I want to look at a simpler problem first. So let's look at this problem right here. Y equals parentheses 2x plus 3 squared. Well, back in the day, what you would do is just, in chapter 3a, you would actually rewrite it and you would square it. And so you rewrite it as y equals 4x squared plus 12x plus 9. And then you do dy dx, the derivative would be 8x plus 12. Well, that's pretty easy. Okay, so what I want to do now is let's keep this in the corner here. And I want to, without rewriting, we're going to use composite functions. Okay, very exciting, very exciting. All right, so what I'm going to do is I'm going to say y is equal to, here's our original problem, 2x plus 3 quantity squared. And I'm going to say, well, y is equal to u squared, and then u is equal to 2x plus 3. So we're going to write it as two pieces. And then I'm going to take the derivative of each one of these. So I'm going to say dy du. So the derivative of y with respect to u just means you're taking that u and you have 2u. All right, and then I'm going to do du dx, the derivative of u with respect to x, which means I'm taking the derivative of x there, and I'm just going to get 2. And this is kind of interesting here. If I multiply these guys together, dy du times du dx. Look at this. Very interesting. Okay, the du's actually cancel out, and we have dy dx. Those du's are actually our link. That's why they call this the chain rule, is because those du's link this together. They link the dy du and the du dx together to give us dy dx. So truly, if I multiply these guys together, which in this case would be 2u times 2, right? If I multiply them together, that gives me 4u, which is my dy dx. And then I'm going to do is I'm going to substitute the u, my value of u that I have here. I'm going to put that into the dy dx, which is 4u. So it's basically 4 times 2x plus 3, which gives me 8x plus 12. Amazing! That is truly amazing. Okay, those are the same. So you're like, well, Mr. Curvis, why would I do all this work? Okay, it's crazy to do all this work just to get the same answer as if I just rewrote it as squared. Well, yeah, but what happens if instead of I squared it, right, cubed, or to the 4th power, or to the 5th power? Okay, then you'd be writing out some brutal stuff, and it would just, you guys would be crying, and it would be really, really sad. Okay, so it comes in handy, not necessarily for simple problems like this, but when you have more complicated problems. So let's go back to our original problem here that I started out with. I said y is equal to sine of x squared plus 4. Okay, so what we're going to do is we're going to say y is equal to the sine of u, and we're going to say u is equal to x squared plus 4. So remember, it's dy dx is equal to dy du times du dx. Okay, so from this equation, the first equation here, we have dy du is equal to cosine of u. And then this guy right here is going to be du dx, which is equal to 2x. Okay? And so what we have is we multiply those together. We have cosine of u times 2x. Okay, then we're going to substitute the value of u, right? We're going to substitute that into that guy right there. And we have cosine of x squared plus 4 times 2x, or just kind of a good way to write this is 2x times cosine of x squared plus 4. And that's the answer using the chain rule. Okay? It's not too bad, not too bad. But again, you would not really be able to do this without knowing how to, use composite functions. All right? All right, I want to try one more problem here. I'm going to show you something kind of interesting. One more example. And this is kind of like what I said before, where it gets really complicated if you didn't know how to use the chain rule. So y equals 5x squared minus 4x to the third power. All right, so again, if you could write this out, you'd write 3 times, multiply all out. It gets kind of brutal, but we're going to have to worry about that. We can just say y is equal to u cubed, and u is equal to 5x squared minus 4x. Okay, so we're going to do dy du, which equals 3u squared, and du dx, which is equal to 10x minus 4. All right, and again, we just multiply them together. That gives us our dy dx. And it's equal to 3u squared times 10x minus 4. Then my last step is to take this, to plug that into there. So we wind up getting dy dx is equal to 3 times 5x squared minus 4x times 10x minus 4. Okay? And this guy is squared here. And that's it, math fans. Now you're like, well, geez, Mr. Curvis, do we need to simplify that at all? No, actually you don't. The main thing that I'm going to be looking for is no negative exponents and to combine to one fraction. So you can leave it like that, it's fine. Obviously, if you have like terms, you want to combine them together. But in this case here, you got a square, we have to do all kinds of multiplication, and you could just leave it like that. All right? I'm just going to cursor down here because now I want to show you something. We're going to call this, it's just really part of the chain rule. We call this the outside, inside rule. And I prefer to call this, I look at it as the Tootsie Pop rule. Okay, because what do you know about a Tootsie Pop? You always start on the outside, right? You lick, and then crunch. Like that owl, I guess, in that commercial, if you've ever seen that one. But you lick, and actually the owl licks it only like 3 times and then bites it, and then you get to the Tootsie Pop in the center. So you got to work from, you can't eat the Tootsie Roll first and then eat the sucker. You got to eat the sucker, then the Tootsie Pop. So you're going from the outside to the inside. You're like, what the heck is he talking about? But anyway, let's do this example. Y equals 5x squared minus 4x cubed. So without using substitution, what we're going to do is we're going to take the derivative of the outside. So we go outside first. All right, so we take the derivative of the outside, and what that is, it's 3. So this is it's like saying, what we did before, we did u cubed, right? And it's like saying 3u squared. So, but of course we're not using u here now, we're saying 3 times 5x squared minus 4x to the second power. That's the outside. Now we're going to take the derivative of the inside. Oh, this is the Tootsie Roll part. Ooh, very excited. And the derivative of the inside is basically the derivative of 5x squared minus 4x, which is 10x minus 4. All right, then we're going to put them together. Kind of like when we're putting the dy du and the du dx together. It's exactly what we're doing. And we just put them together, and we get 3 5x squared minus 4x quantity squared times 10x minus 4. And we get the derivative. Amazing! Amazing, amazing. It's the same thing. All right, so again, you guys are saying, well, why did you show us the u-substitution is much more difficult? Well, you know what? You need to kind of understand where things came from. Okay, as opposed to me just saying, oh yeah, here we go. This is the outside-inside rule, and it's just like a random rule that we just came up with. All right, so it really is with substitution, but it's just an easier way to go about doing it. All right, so let's do another example here. Y equals 2 times x squared minus 3 to the 4th power. Once again, yesterday you would have cried because you're like, oh, this is brutal. This is, you got to write this 4 times and it's brutal. But we just have to use we'll call it the chain rule now. It's really outside inside, but it's the chain rule. And one thing I want to mention with this, math fans, is please don't look at this problem now and say, oh, I have to use the product rule because I have a 2 times that. You got to look at it as the 2 is on the outside. Okay, 2 is like your constant. So when I say dy dx, don't just leave the 2 on the outside. It's really 2 times the derivative of x squared minus 3 to the 4th power. Okay, because if you try to make it do it, the product rule, I mean, it does cancel out because then you say the first times derivative of the second plus the second times derivative of the first. Well, the second times derivative of the first gives you 0 for the 2, and that cancels out. So, I mean, you can do that, but I think it's just a lot more work. So I would not do that. I would just treat it as a constant on the outside. All right, so let's do the chain rule. And by the way, this is going to be multiplication here. There's a lot of multiplication when we're doing the chain rule. So the first thing is we're going to do the outside. So that's 4 times x squared minus 3 to the 3rd power. All right, so again, it's like that u to the 4th power, right, is 4u to the 3rd power, and that's exactly what we have here. 4u, which is x squared minus 3 to the 3rd power. All right, and then we take the derivative. So that's the derivative of the outside. Now we take the derivative of the inside. Well, what's the derivative of x squared minus 3? It's just 2x. And again, this is pretty huge here. It's all multiplication when we're doing the chain rule. Please don't start writing like plus 2x, whatever. It's all multiplication. All right, and then you got to simplify it as much as you can. Okay, which means you're basically multiplying the constant terms, the variables together. Obviously, you can't do anything with that x squared minus 3 to the 3rd power. I'm not looking for you guys to write that 3 times and expand it, but I am looking for you to go, oh, 2 times 4 times 2x gives you 16x, and then times x squared minus 3 cubed. And that's your answer. Okay? Not too bad, right? Not bad at all. All right, so a couple things I want to mention here, math fans. First of all, I'm going to put a couple stars here because I want no negative exponents. We actually did that last part of the chapter. So no negative exponents, and I want you to combine. So no negative exponents, and combine to one fraction. Okay, so no negative exponents, and I want you to combine to one fraction. So let's start with an example here. F of x is equal to the square root of 6x minus 7. Now personally, if you're trying to work with radicals, that's kind of brutal. You guys want to make sure you deal with rational exponents. It just makes so much more sense. So I'm going to rewrite this with a rational exponent. I can right here, rewrite with rational exponents. Okay, so I get 6x minus 7 to the 1/2 power. Much easier. So now we're going to do f prime of x. And we're going to do the outside to the inside. Make sure you do outside to inside. Tootsie Pop, outside to inside. So it's 1/2 times 6x minus 7. And what do you do with that 1/2? You subtract 1, so it's really to the negative 1/2 power, right? And then I take the derivative of the inside, which is just 6. So I get f prime of x equals 1/2 times 6 is 3, and it's 3 over the square root of 6x minus 7. And I don't care if you leave it as 6x minus 7 to the 1/2. That doesn't matter to me. Okay, but don't have negative exponents and always have one fraction. All right, that's not too bad. Let's try another example here. F of x is equal to x plus 2 over x minus 3 quantity cubed. Okay. Again, that would be brutal if you try to do it the way we did it back in the day, but now we're going to just use the chain rule. So f prime of x. Okay, so the first thing we're going to do is we're going to do the outside. So it's going to be 3 parentheses x plus 2 over x minus 3 to the second power. Okay, and then it's times. Remember, it's always multiplication, and we got to use, for this one, we're going to use the quotient rule. So it's the bottom. Remember, quotient rule is always, you start at the bottom in corporate ladder. So quotient rule is the same thing. You start at the bottom. So it's bottom times the derivative of the top, which is just 1, minus the top times the derivative of the bottom, which is 1, all over the bottom squared. Okay, and so I simplified a little bit. We're going to do, let's see, I can do this. And really the only thing I'm simplifying is if I multiply this top part out here. That's, you want to make one fraction. So we're going to say x minus 3, and then make sure you distribute the negative. Don't do goofy algebra mistakes. Minus x minus 2 over x minus 3 quantity squared. So we get, let's keep writing here, x plus 2 over x minus 3 squared, and it's times, the x's cancel, and you guys agree we get negative 5 over x minus 3 squared. Okay, and so let's see, let's keep going here. And I'm going to get, basically you have, I guess we can show a little bit more work here. Okay, and then let's put all together. Of course, x minus 3 squared times x minus 3 squared. My denominator becomes x minus 3 to the 4th power. And on top, I get negative 15 times x plus 2 squared. And again, I don't need to simplify that any more than it is, and that's my answer. Okay, not too bad, not too bad. Okay, let's try another one here. Got 2 more examples. Let's do y is equal to cosine of x times 2x plus 3 to the negative 4th power. Okay, looks kind of brutal, right? Yeah, kind of. So, you could do it both ways, but I like to have positive exponents, so I'm going to rewrite with positive exponents. The only reason I'm doing that is because I know my final answer has to have a positive exponent, so why not just rewrite it with them and not deal with negative exponents right away? So I get y is equal to the cosine of x over 2x plus 3 to the 4th power. Okay, not bad. And so dy dx, we're going to just do quotient rule, so it's bottom, which is 2x plus 3 to the 4th power, times the derivative of x, or derivative of the top, which is negative sine of x, minus the top times derivative of the bottom. Derivative of the bottom. What we have to use here, we got to use the chain rule. So it's going to be 4 times 2x plus 3 to the third power, right? Times the inside, which is 2. Okay? And then, of course, it's all over 2x plus 3 to the 8th power. Okay? So let's put some stuff together. dy dx is equal to, let's just write negative sine of x times 2x plus 3 to the 4th power. We can put some stuff here. So it's minus 8 cosine of x times 2x plus 3 cubed all over 2x plus 3 to the 8th power. Okay, and I can factor, so dy dx, right, you guys agree I can factor 2x plus 3 to the third power out, right? So let's just do that. 2x plus 3 to the third power times negative sine of x times 2x plus 3 minus 8 cosine of x all over 2x plus 3 to the 8th power. And so that cancels. That goes to a 5. Let's keep going down here. We get dy dx then equals negative sine of x times 2x plus 3 minus 8 cosine of x all over 2x plus 3 to the 5th power. Okay? Yeah, it looked a little complicated, but just, there's so much algebra here, math fans. The calculus is really not that bad. You just have to know, product, quotient and power rule, chain rule. You have to understand that, and you got to just be really careful with combining like terms and simplifying things. All right, because they're going to be looking for lots of details. You got to look for the details in your, when you're doing your AP problems, because they're going to be looking, at your work. Okay, so don't skip any steps. If you're ever concerned about, should I show this or should I just go and not show it? Show it, because you're better off showing more work for the AP grader than less work, because the answer to the problem might be worth 1 point. And the work to the problem might be 9 points. It might be a 10-point problem. And you might have the right answer, but if you don't have the work to support it, you're not going to get all the credit for it. So it's kind of brutal to lose points when you really know what you're doing and you just don't show it because you're like, I don't need to show the work. If ever in doubt, show work. Okay, last example. Y equals 2x times the square root of x squared minus 6. Okay, that's kind of a brutal problem if you didn't know how to do the chain rule. Okay, so what we're going to do first is I'm going to rewrite this with rational exponents. Just makes it a lot easier. So 2x times x squared minus 6 to the 1/2 power. And then dy dx, do the derivative. And so we're going to do the first times derivative of the second. So it's going to be times, well, of course we're doing the chain rule, so 1/2 x squared minus 6 to the negative 1/2, and times the inside, which is 2x. So it's the first time derivative of the second, plus the second times derivative of the first, which is just 2. Okay, so let's kind of put some things together here. So dy dx, and I'm going to get 2x times 1/2 times 2x gives me 2x squared times x squared minus 6 to the negative 1/2 plus 2 times x squared minus 6 to the 1/2. All right, and I want to write it as let's give a positive exponent here. Dy dx equals 2x squared over x squared minus 6 to the 1/2 plus 2 x squared minus 6 to the 1/2. Okay, let's move this down a little bit. And what I want here, math fans, is you want one fraction. It doesn't always happen that way. Now this one's actually pretty easy to do it because what I would do is, let me get rid of, I just wrote this one fraction here. Okay, basically multiply this guy right here times x squared minus 6 to the 1/2 over x squared minus 6 to the 1/2. Do you guys agree? I'm just basically I'm getting a common denominator. Okay, I would say I was rationalizing, but I'm not even rationalizing. I don't care about having a radical in the denominator. I'm literally just trying to get a common denominator. So I multiply because I need to have this denominator here as well, right? To be able to combine them together. Okay? So we get dy dx is equal to 2x squared plus, now this is the deal, when you multiply these guys together, all right, that just gives you, it's like the square root of x squared minus 6 times x square root of x squared minus 6 just gives you x squared minus 6. So I really have plus 2 times x squared minus 6 to the 1 power, right? And then this is all over x squared minus 6 to the 1/2 power. So dy dx, that's going to be 2x squared plus 2x squared minus 12 over x squared minus 6 to the 1/2 power. Okay, and then of course combine the terms. So dy dx is equal to 4x squared minus 12 over, and again, you know, I don't care if you write it at the square root or to the 1/2 power, doesn't matter, x squared minus 6, the square root of that. Okay? So that's really not that bad. Again, watch your algebra, make sure you give me one fraction, no negative exponents, and you're good to go. All right? That's it, math fans. Have an outstanding day. Adios. Goodbye.